Mm, Can you guys see? Let me see. Okay. Can you guys see my screen? Can I have someone type in the comment section and let me know if they can see my screen? Is there anyone who can see my screen? Can you please type in the comment section and let me know? Mm, I'm getting no response, so I don't know whether I should assume that everything is working. Okay, that's good. So if you can see my screen, then perfect. So let's get started. So I'm going to close some things here. So welcome to today's tutorial. I'll be explaining the practical, right? I'm not gonna give you the memo, right? I'm just going to explain the practical to to give you information or tools that you have to use to do the practical, or a set of tools that you may or may not use. That's up to you. But then I think you should use them based on the practical requirements. So the purpose for this assignment is for you to get comfortable with basic data types and C++ expressions. So the whole point of this practical is so that you guys get to understand what are C++ data types and how to use them, and what are C++ expressions and how to use them. That's the whole point behind this practical. They just gave you a problem. It can be any problem. It doesn't. That's not the point. The main point is how do you apply those topics that you've been taught in class, which is basic data types and C++ expressions. So I'm going to solve my own problem, even if it's like a stupid program or problem, it's fine so that you can get to see the output, right? And I'll structure the output in such a way that it's easier for you guys to sort of like mimic or link or relate relate to this practical. So let me see. So the following table displays the temperature in Johannesburg for the past 10 weeks in degrees Celsius, right? So we have week 1, week 2, week 3, up until week 10. So the degrees can be converted into Fahrenheit in using the following formula. So these are the instructions. So the instruction is to write a C++ application that compiles that compiles with the following requirements. So your C++ application, it should work, right? And then since it's going to work, it should follow the specific requirements. So it should be based on these instructions. So what are the instructions? Each week's temperature must be stored as an integer variable, right? That's the requirement number one. And then they tell you that you may hard code. By hard code, right, what does hard code mean? Some people might not understand since it's your first time um, being it's your first time seeing computer programming, right? Hard code, it just means you put in the values. So when you create the variable, you give them values. So basically when you create these temperature variables, each variable must give it a random value, any value that you can think of, right? But then it should be a value that's reasonable. You can't put 1 million There's no 1 million degrees. It wouldn't make any sense, right? So that's why they gave you this example over here. So what I'll suggest, right, what I advise you to do is just use the values that you already given to make things simpler for yourself. And then the name of each week, right? Week one must be stored as a constant string variable, right? So you must store the weeks, right? So you must store the string. Yeah, this is quite a challenging practical, especially for beginners, because C++ is I wouldn't say it's a very friendly language for beginners. You need to know what you're doing. So what this means, right? So let me open Notepad, and then I'm gonna type in one by one like the requirements, right? Then I'm gonna solve my own problem in such a way that's similar to this practical. Because you guys, this is your practical, you guys still need to do it. You may hard code the values into the program, blah blah. The name of each week must be stored as a constant string. So there's a lot of things involved. I would advise you to watch that video that I sent in the group chat that explains, that introduces you guys to programming in general. And I think I do also talk about data types there. And I talk about them extensively. Like I put in a lot of information there in the video. So for the sake of time, I'm not gonna go into that. I'm just gonna use the types. I'm not gonna explain them too much. If you want more explanation, watch that recording, the link that I sent in the group chat. Calculate the average weekly temperature using a C++ expression and store the result. Create const variables to store the terms necessary to perform conversion using appropriate data types. Convert the average temperature from degrees to Fahrenheit and store it as a double. Output the, or from degrees to Fahrenheit. Output the weekly temperature readings in tabular format as shown above in a user-friendly way. Output the following below in the table. You need to, or output the weekly temperature. Okay, so there's a lot of things you need to output. So number one, they want you to output the weekly temperature. See how it is right here, right? As you can see here, we have it in this format. So you would have to output in the table format. They mean it when they say table, they mean it. They mean table format. So when you run your C++ application, whether using code blocks or a batch file, I'm not sure which approach did Dr. Stung suggest for you guys to use, but whatever approach you use, when you run your program and it gets opened by it opens on the terminal, you would have to output it in table format. You have to output week one followed by space, output week two followed by space. So let me make an example. So you have to output week one, and then yeah, you have to output it like this, week one. You can, to be honest, it's up to you. You can output it like this and say week one combined like this, right? Or week one with the space. Then after week one, there's a space, and then you output week two, and so on until you get to week 10. And then in the next row, you output the value for each week, which is the temperature. Yeah, it's the temperature. You have to output the temperature. So by temperature, it means these values. So remember, in step one, you have to create the variables, which is going to be 10 variables. From week 1 to week 10, it's 10 variables, and they have to be of type integer. They did tell you it's integer. So that means you're going to have, before displaying, you're going to have all those variables, right? You're going to have int week 1, and then int week 2, and so forth, right? Then these variables, you're gonna give them values. Remember, must initialize, give them random values. But like I said, I would advise you to use these values that are over here. So if for week 1, you must use the value 28. Week 2, use 22, as given to you by the practical instructions. Just use those values. They said you may hard code the values, meaning you can put them yourself. Basically, it means do not ask the user to give you the value. For example, when you go to Ulink and you log in, it asks you for your details, right? You must enter the details. But then in this practical, it shouldn't be like that. You shouldn't ask someone else to put it. You put the values manually. That's what it means. When they say hard code it, you have to put it manually, meaning every variable you create, give it your own random value. So after you've displayed this, then it should output, after week one, it outputs 20, under week one, outputs 20 or 28, right? Because I'm looking at the examples that are used in the practical. Week two is 22. So like this, so they want it in this table format. That's what they mean. It has to be in table format. It's strictly table format. Or else you're gonna lose marks for your practical. So for now I'm just explaining how they want you to approach it and things like that. I'll make my own example after explaining how they want you to approach the practical. So the name of each week must be stored in a const string variable. So const string, so what is a variable, right? Let's just talk about the variable. So if you look at the word variable itself, right, it's derived from the word vary, right? Or varies, meaning that it changes. It's just a fancy English word to say it changes. So that means if it was 20 here, I can change it to 25 later and change it again to 10 or change it to -2. I can always change it. That's why it's called a variable, because it varies or it vary or it changes. That's what the term variable means. It means that it changes. So for example, um, so what example can I make? The weather, right? Let's we can view it as a weather. Like I can use an example of the weather. The weather changes, right? It varies. So in a way, we can say that's a variable. It's something that varies. So I want you to use something that I like to use when I see an English word that I do not understand very well. I break it down. So if you look at the word variable itself, it is, look at the word that you're able to break. I know this word able, right? So if I remove able, I'll be left with vary. So it'll be like this. But then vary, I'm just missing an e this and an s, so that it's very, it is, so that I get the word varies, right? So varies means change, right? So able, you can switch them around and say able varies, right? I know it makes no, it kind of not make sense, but this is how I tend to break down English words that I do not understand. You realize that you actually do understand the word, you just don't know how to approach it and break it down. So it's able varies, but then I can structure it in such a way that it kind of sounds like a sentence. So it's able to varies, or I can just change it to the word vary instead of a plural and just use the singular. So it's able to vary, or it's able to change, hence variable, right? So that's what it means. So when they say constant, what do they mean by that? They mean that it's the opposite of a variable. That's what it means. So when they say create, when you see a term that says create a constant variable, right? They mean create something. The thing is, that's the only way you're able to create it. It has to be a variable first and then restrict it from being changed. That's the only way you can create it in C++, right? That's why they use, that's why they, I know it wouldn't make any sense. You can ask yourself, how can you make something that changes become unchangeable, or to not be able to change it? Because by definition it means that thing should be able to change. Well, the thing is, C++, it approaches it in that way. That's why they say create a constant variable. So what's the one way to create a constant variable, or what's the how do you do that in C++? You simply create a variable again. So let me use pi, right? Semicolon, right? And then I'm gonna initialize it to 3.14, I think 1459, I'm not sure. I think so. So there's pi, but then remember pi is it does not vary, it does not change. So therefore, how do I tell C++ that it shouldn't allow people to change the pi variable? I put the keyword const before the data type. So I'm gonna say const before the data type. And please guys, spaces are very, very important. If you wrote this in one word like constant, you see it's no longer highlighted, meaning that C++ does not know what you mean. It has to be highlighted in blue so that you know that you're on the right track, especially when you have things like const or data type. It needs to highlight in blues. C++ needs to know, oh, you mean int data type. Oh, const, you mean const keyword. Okay, I understand. But if you don't put any spaces, leave it like this, error, your program crashes. And remember, when you submit your practical and your program crashes, it's kept at 40% maximum. So you don't want that. So make sure you put the spaces in the right place. So you say const and then space and then the data type and then space and then the variable name. So this will be the formula. You use the const. Okay, so let me make it a comment. So you're gonna use const followed by this space. I'm sure you can see the space. And then followed by the data type, right? Followed by space again. There's that space. And then followed by the variable name, its name, right? Then followed by a semicolon. And then since it's a const variable, right, you are not allowed to create it without giving it an initial value. That's a rule in C++. You cannot do, because for you to say it's something that does not change, that means it needs to have something. So for example, you can't say pi does not change, but then what is pi? You need to give pi a value that does not change. So therefore, the only way you can create a constant variable is to always have an equal sign and then give it a value, right? So this will be the value or a number, whatever number it is. So as you can see in line 5, I did exactly that. I followed the instructions. And do not forget, when you create a constant variable, you always give it a value. Remember, variable, it can vary, it can change. So I don't have to give it an initial value. Okay, I don't need to give it a value, but you're advised to give it an initial value. But I can declare a variable in two ways. A constant I can only declare it in one way, only one way. You use the keyword const followed by a space, followed by the data type, followed by a space, followed by a variable name, followed by a space again, followed by the equal sign, followed by a space, followed by the value, the number that you want to set it to, followed by a semicolon. Remember, we talked about semicolon. A semicolon, it acts like a full stop, just like in English, right? Or any language. You put a full stop to say this is the end of this sentence. In C++, sentences, we call them statements. So how will C++ know that's the end of the statement? You put a semicolon at the end. You don't put it crash. That's a computer. It is zero tolerance for people who are not accurate. You need to do exactly what you're supposed to do, or else it's gonna shout at you and you're gonna see red everywhere. So we understand what a const variable is, and they say the string. So that means you must create a string. You must use the string data type, and then calculate the average weekly temperature using the C++ expression and store the result in a double variable. By double variable, they mean its data type should be a double. It's a variable, and then its data type should be a double. That's what they mean by a double variable. So you must calculate the average, right? So you must calculate this average for this week, right? Meaning that you must add, for those who do stats or they do still remember high school, that's what we call the mean value, right? You need to find the mean or an average in mathematical terms. In statistical terms, we call that the mean. And then create const variable. We see const again. And if you don't know why it's called, why they say const, if you look at the word constant and you remove ant, you are left with const, meaning that it's a constant. It doesn't change. It's constant. I think that should be self-explanatory. And then they say using the appropriate data types. So they say to store the terms necessary to perform conversion using the correct data types. And then convert the average temperature from degrees to Fahrenheit. So to convert, there's the formula here. That's the formula you're gonna use. This means degrees Celsius. This means Fahrenheit. Then that's the formula. And then I'm gonna teach you a trick. I'll make an example right now. You'll see. I'll make an example. So and then output the weekly temperature readings in tabular format as shown above in a user-friendly way. So they mean output it in that table format. We talked about that. And then after you've outputted that thing, you must output the following: the average temperature in degrees Celsius and the average temperature in Fahrenheit. So this is what they mean, right? So if you look at number 4, if you don't understand what number 4 means, right? They say create const variable to store the terms. What do they mean by terms? They mean Celsius and Fahrenheit. Because you can't just imagine you went to Eve, right? And you saw, no, should I say, let me use Ulink, right? So let me say Ulink UJ, right? So let me just use Ulink. So let's say you go to Ulink, right? You are trying to log in. So there's Ulink. Imagine if this label was not there. How would you know what exactly must put in here? Imagine this password label was not there. How would you know that you must type in a password? That's what they mean by terms. So before you display the average, tell us what that average is. Is it the Celsius? Is it in Celsius or is it in Fahrenheit? That's what they mean in number 4. So you must basically put labels for your each value should have its own label. That's what they mean. So that's pretty much what you must do for the practical. There's nothing more fancy about it. So I'm going to make an example that's similar, right? That's exactly similar to this. So my example, right? And mind you, the example that I make, you can easily borrow from that example to solve the practical, right? The main thing is to understand the tools that I use to solve that problem. So my problem is that let me see. Let's say we are selling we are selling what are you selling? Let's say you're selling sweets, right? And then you want to keep track of the price of or your income for all the days of the week, right? So Monday you got this amount, Tuesday you got this amount, Wednesday and so forth, right? Up until Sunday. So you have Monday, and then you have Tuesday, and then you have Wednesday, then you have Thursday, and then you have Friday. So I don't want to type too much or have a lot of things. I'm just gonna stop at Friday. Let's say weekend you're resting, and then Monday you start again. So you're selling sweets. So for me, let's say I'm gonna use rent, right? So because you are used to rent, let's say you're selling sweets, and then let's say Monday was a very slow day. You got 50 rand. Tuesday you got something 200, which is a huge improvement, and then Wednesday you got 350, and then Thursday you got 150. Friday you got 120, and then my problem, right? The problem that you must solve, it's similar to that practical, right? Exactly similar. But then the problem is I'm solving a different. The only difference is that I'm solving a different problem. But I'm gonna use the same tools that you're gonna be need that'll be needed to solve the practical, right? Don't be like say is not showing us. I want the memo. Me, I just want the answer. No, that's not how it works. You must go attempt the practical on your own. Me, I'm gonna make an example that's exactly similar to the practical. You just have to use your brain and see, oh, so if he did it if he solved this on on his problem, that means, oh, I can use it to solve that part of the problem for the practical. So I want you to think in that way. So my practical, right, or my problem is that you must output sum, which is the total, then output the average to see on average how much you make. That's my practical, right? For me, right? That I'm going to solve. And I'm gonna use code blocks, right? You can use, okay, let's use code blocks, right? Let's use code blocks. Remember, I think I showed you guys how to download code blocks. You just go to your browser and then you search code blocks, then you click on the very first link. It should be the first link. Then on this side, right, you see on this grayish side, you click on downloads, right? Click there. Okay, there's a lot of ads, and then I'm gonna remove the ads. Then you click download the binary release. You don't want any other things, right? You want the binary release, not the source code. The source code is actually it's like C++ code. Why would you want to see C++ code? Because you want the code blocks app itself. You want to run it, right? So you click here, download the binary release. Then it's gonna load. Then it's gonna show you different operating systems. You will choose Windows if you're using Windows. Choose Linux if you're using Linux. If you're using a MacBook, choose this option here. But then for MacBook, apparently it's a bit shaky. I don't think you can run it, but you'll see, right? You test it out. If you can't, then find other means of running it. I'm using Windows, so I'm gonna choose the Windows option. Then remember, I talked about your laptop, right? The architecture of your laptop. If you're using 32-bit, make sure that the executable file that you're downloading, it has Ming W in it, because that Ming W, right, it comes with the compiler. If you choose this one without the compiler, you have to download the compiler separately on your own, of which I showed you how to download the compiler, so you can choose any option that you're comfortable with. But then I would advise you to choose this option because it's straightforward. You just download and then install, done, and then you start coding. This one that I've highlighted is for people who have a 64-bit architecture system. And then the 32-bit one is there at the bottom. It's here, second from last. You must make, like I said, make sure you choose the one with Ming W. And then you download, follow the instruction, and then done. So there's your code blocks. It's installed. Then you're going to open your code blocks, right? So here's my code blocks. So let's start solving the problem, right? So one thing that I want you to notice or to take note of is when you're creating constants in C++, right? It is advised that you create them outside the main function, right? You should normalize doing that. So for me, I'm going to create an, okay, so I'm sorry about that, moving a bit too fast. So you're gonna get to this page, right? When you open code blocks. Then the first thing that I want you to do before you create the C++ project, go to settings here at the top and then select compiler and then choose the compiler here. Make sure you choose STD is uh, C++11, right? Or C++14 if the option is there. The thing is with me, right? I installed my compiler separately and things like that, so some options are not shown here. But then make sure you choose the one that is GNU, right? Which is GNU. It is GNU in it, right? To make sure you choose that one. So let me show you an example here. So you see that I have this over here and then I have this one. I would advise you choose this one. You see it is C++ 98 there. This is the 1998 version of the compiler. You don't want old ones. You need, like I said, C++11 or C++14. Choose one of those, which is a bit modern. So less, most features you can put in those compilers. So make sure, okay, it's the one, I think it's gonna be written ISO, right? Yeah, it's gonna be written ISO. It's gonna be exactly like this on your side, but then don't choose the 1998. Me, I'm only seeing these options because I installed the compiler separate. Here where it says 1998, for you it must either say 2011 or 2014. And make sure it is C++11 here or 14. If you're choosing if you chose 2011, it's gonna say C++11. If you chose 2014, it's gonna say C++ 14, and make sure it is ISO or ISO in it. Then you're gonna click select here to select it like this, and then you click OK, and then you're done. So that the compiler is ready, right? You've set it, you've linked the compiler. And once you're done with that, you're gonna click create a new project, and then choose console. We are making console applications, and then click go. You're not doing C, you're doing C++. So make sure the blue color is on C++. Then click next, and then give your project a name. So I'm gonna call mine Sweets, right? Simple. And then you can choose the folder to save it in. So I've saved it inside the specific folder. You can click these three dots here, click them, and then it's gonna open your file explorer. Then you choose the folder that you want to save the projects in. Once you've selected the folder, then you're gonna select the folder. So let's say it's this one, you select it, then you click select folder. So that means every time you create a project inside CodeBlocks, it's gonna be saved in that folder. That's how you find the project. For me, I already selected, so I'm gonna click cancel, and then click next, and then make sure you choose the GNU GCC compiler. By default, it's already selected. When you're installing it, right? Yeah, I forgot to mention. When you install it, it should say you should select the GNU GCC compiler. But by default, I think it does select it for you. So all you have to do is just keep on pressing next when you're installing it. Then click finish, and then done, right? Then you click on sources, double click, not just one click, double click on sources, then double click on main.cpp, and then there's your code. Then you just zoom in, right? But then for you guys, I think you must use a page file, if I'm not mistaken, because I've created this project, right? So I'm gonna go to documents and then go to code blocks projects. I called my project suites, so there it is. So yeah, you see that there's no source folder, there's no src folder here. There's nothing. But then let's run it. Let me just build and run. So to run, right, there's two ways of running it. You build and then run. To build is to compile it, right? It is to translate it into the language of the computer. That's what the build button does. To run it is to take that file which is the language of the computer and run it and tell the computer to run it, since the computer can understand that language. But then you cannot run without building, so you need to build first. So the best thing to do is to do both simultaneously, which is build and run. So it starts by building and then runs. So I'm going to click that option for building and running, and then boom, there's the console. So this is what we call the console, this black thing here. It's called the console or the terminal. That's where you want to see your output. And then it's just hello world, and then I'm going to close. Then I'm going to go back to my folder, right? There's the bin folder, and then debug, and then suites.executable.exe. So this file that it created here, it's the file that is the language of the computer. So it took my C++ code, which is all of this, right? Then it translated it to the language of the computer and created a file that ends in a .exe. If you're on a Linux operating system, it's gonna end in .out, right? And then on a Mac, I do not know. I don't have any experience with using a MacBook. It should be you should know if you're using a MacBook. You know how the executable files are. So this is the language of the computer. You see how complicated it is? Very complex. Some characters you cannot type them with your keyboard. So that's why we learn C++, so that we don't have to type this manually, because it would be impossible. Everyone would fail computer science if there was like everyone would fail. So hence the C++. So next time you see C++ and you wanna cry, there's no reason to cry. That's actually having it the easy way. Programmers back in the days, they used to write it in the language of the computer, which was extremely hard. So it was definitely harder than doing medicine, computer science back then. Way harder, because you have to speak the language of the computer. So yeah, so this is easy, even though it looks complicated, but this is the easy way. So we have our program, right? So let's look at the practical, and then I'm going to solve it one by one, right? Each step. but then I'm solving my problem, not the practical. So each week's temperature must be stored in integer variables. So each week's temperature, meaning these temperatures here, 28, 22, those values, they should be stored in integer variables. So for me, in my problem, right, I have sweets, right? And I have for Monday, Tuesday, Wednesday, and so forth, right? So I'm going to create variables and name them Monday, Tuesday, Wednesday, Thursday, and Friday. That's how I'm gonna name my variables, which is good. Remember, in naming variables, give them names that are easy to understand for other people, right? It's very important. You do that. So let's store the integers, right? And they said integer. Pay attention here. They said integer, meaning it's int. If you check when I was declaring here, this is an integer. How do I know? Because int comes from the word integer. They just removed e and g and e and r like this to be left with int. So this is the C++ way of saying this is an integer. So you just type in int or int to say to tell C++, listen, create an integer for me. And then remember what we talked about in C++, right? Okay, in C++, constants, you declare them outside the main function. You see outside here, meaning after using namespace standard, you declare your const here. That's what's advised by people who who created C++ and people who use C++. So I suggest you do the same. And then anything else can be created within this function. So within these two curly braces, this one and this one, but before this line, you see this line over here? That's the last line that should always be there. If you try to write anything after here, it's not gonna work, because when it gets to this line, it stops checking everything else. So order is very important. So I'm gonna remove this output statement here, and then before this returns 0, before it, that's when I should start typing. Then I'm gonna create my variables. So I'm gonna put in what we call a comment. Remember, a comment is like notes. You're writing notes to yourself. So for example, imagine you're doing maths, right? And you're solving an equation, and you solved and you finished. But so that you don't forget, you take a pencil and then you add notes on the side that, oh, here I was completing the square. Here I was using the quadratic formula. Here I was using this. So that when you go back, maybe 10 years later, you go back to that notebook, you look at it and look at what you've solved and see how you solved it by looking at those notes you wrote in pencil. So that's the exact same thing we're doing here. So that in the future, when I look at my practicals again and I forgot C++, I can easily know what it does, right? Even though I forgot how to write in C++, but I know what it does because I left comments. So I'm going to put in 2 forward slashes like this, and then space. Don't forget to put the space. Then I start explaining what my code should do. So C++ just ignores that because it's just a comment. It just ignores it. It's just for you, for yourself, or for other people who are going to look at your code. So here I'm going to say create variables, right, of integer type. So I'm going to create variables of type integer. And then after that comment, so the comment goes up until the whole line is going to be treated as a comment. But then when I write in the next line, it stops treating it as a comment. It's now going to execute it as a C++ statement, right? So let me create my variable. So I'm going to have int Monday, int Tuesday, then int Wednesday, and then int Thursday, and then int Friday, right? So these are my variables. So step one, it's almost done. I'm just left with one thing. You may hard code the values. So they want me to put in the values. So that means I need to initialize these variables with the actual numbers or values. So I'm going to go down, where is it? So I'm going to use this. So 50 200. So I'm gonna initialize this to 50. Remember to put the space before the equal sign and the space after the equal sign. Mind you, still gonna run, right? Even if you wrote it like this, it's gonna work, but it's advised that you don't do that. Don't be a person who's just so untidy. Everywhere you're untidy. In your room, you're untidy. At school, you're untidy. When you dress, yeah, it's just untidy. Try to be neat somewhere because it makes it easier for other people to read your code. Because remember, when you go to the industry and you start working, you'll be reading other people's code. So you don't want people to be pissed off at you, and there's fights in the workplace. So try to follow the culture, right? If they tell you normalize putting spaces, normalize doing that, do that. Don't be untied. And see, it'll still work if you did this, right? I think so. It should work. But then look at how I don't even know what's going on at this point. I don't understand. So you can it's I know some people be like, yeah, being untied is not a problem. Okay, can you understand what's supposed to happen here? You don't, because there's a lot going on there. That's why you need to be tidy. It needs to be clean. Put it in one line, put spaces there. Simple. And then this one should be 200, and then this one is 350. Then this one's, I need to check the values again. It's 150 and 120. Okay, so 120, then 150. So these are my variables. So I'm done with step one. That's already done. I've created my variables. I've stored the values, right? For my problem, I'm keeping track of my profits for my business for my business whereby I sell sweets. I'm keeping track of my profits. That's what my app does, or that's what my practical does. Your practical is in a total different. It uses a total different approach. So number two, or step two, the name of each week, right, must be stored as a constant string variable. Number one, you need to know what a string is. And then number two, we understand what a constant is now, right? We all know that it's a value that does not change. Hence the word constant. It's constant, just like constants in maths, right? There's Euler's constants. There's that you're gonna use in log when you're doing logs, right? Logarithmic equations, right? You're gonna use Euler's constant. And then there's pi, which is a constant. Pi does not change. So that's what constant means. And then a string, what is a string? A string is basically text, right? Anything that basically a string in C++, right? The way I can put it is anything that's in between these two sets of double quotes. We regard that as a string, or C++ treats that as a string. A string of characters, right? What is Remember in high school you used to say A, B, C, D, blah, 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 or A, E, I, O, U, whatever. Whatever you're doing there, you're you're um you're speaking or saying out loud the letters of the alphabet, right? Those letters of the alphabet, right? Letters of the alphabet, you can call them characters too, another word. Instead of letters, we can call them characters, right? So I'm saying characters in plural because if we count from A to Z, that's more than one letter, right? You have A, you have B, you have C. So that's a collection, right, of letters. Hence I said letters. But if it's one, right? So if it's only A, let's say it's A. We would call this a letter, right? Singular. I know it might sound stupid, like why is this explaining something that we already know? We'll get to that. Patience. We'll get to that. Why I'm going, why I'm doing this. There's a reason. So letter singular. So that means another word for that I would say character. Since it's singular, character, right? So now let's look at the definition of what a string is. A string, you can use the word itself to define it, right? I know it sounds weird, but then I think it's best to use the word itself so that you understand it better. So a string, I'll just basically say this is a string of characters. So what do I mean by that? if you remember, I'm sure you still remember when you go to the malls, right? I agree, those people who sell inside the mall, like outside the shops, but inside the mall. And then they sell those beads and what, or those name bracelets. You remember the name bracelets, right? So you remember the name bracelets, these ones. I can see it's there on Temu. These name bracelets, if you remember when you used to buy this and you buy for your girlfriend, or you put your name there, or you buy something and says I love you, blah blah blah. These are letters, right? And if you look at this part, what keeps them together, it's a string, right? That's what joins them together. So that's where the programmers got the idea to call it a string inside C++, because it's literally a string of characters or a string of letters. As you can see, this is a string and it has letters in them. And when you combine these letters using the string, you form what we call a word or a sentence, right? So, for example, if I join HAPPY, if I join all of these letters using the string, I form the word happy. So that's why I said you can use the string word to define the string itself. That's why I did that on purpose so that you really understand what it means. So this string of characters, they want you to make it a constant. We should just gonna use the keyword const. Simple, right? It's easy, right? And remember what I said, you need to put it outside the main. This is what we call a function. If you remember functions in high school in maths, the function is basically something that you put in something and then it takes out something, right? So, so if you remember in life sciences, right, the reproduction life cycle, whatever. Mind you, I never did life science, but those who did it, they will understand. But then even if it didn't, it's basic knowledge. So in order, how is the child, how does one get pregnant? I get it, the sperm has to meet the egg, and then when they join, something comes out, right, which is a child, which is a living object, or a human being, right? So it's the same thing. You put in something and something comes out. So that's a function. I want you to picture it in that way. You put in something, something comes out. But then sometimes, especially in coding, right, it's not always the case that something comes out, right? You don't always get back something from functions. You'll get to understand better when you guys start doing functions. But then I want you to understand for now, functions, because I want you to think of it in terms of maths, because in maths they always return something. So for example, remember when you had f of x and then its formula was, I don't know, x squared or whatever, but then let's say x squared, right? I'm gonna use this to define squared, because you can't remember, this is a computer. It's not a chalkboard, right? I can't write squared because it's a computer. But then imagine that means x squared. So that means if I want to find f of 1, this will be 1 squared, which is just 1. Or or f of 2, which is going to be 2 squared, which is just 4. So I think you get the formula. So this function is called f, and I put in 1 to it, and then it spit out 1, or it gave me back 1. So you see, I put in something and then I got back something out. So that's what it means. So when you see this line return 0, it means give me back 0. That's literally what it means. So when this function is called, it should give back 0. So main, as you can see, this is main, right? Isn't it similar to this function? But then remember what I said, not all functions take in something. You see this inside here, it's empty. It doesn't take in anything. So, okay, it might give you back, it doesn't, okay, I'm mixing them up. It doesn't always have to take in something, which is fine. You understand that part. And it also doesn't always have to return something. This one does not take in something, but it does give you back something. So when you call this, you should get back 0. That's main function. For you won't understand what's the significance of this 0. This 0, it's meant for the operating system. It's meant for the operating system to know that everything went well. That's all. I know it's fancy. It's a 0. It's like, why are we taking all those extra steps? Well, you have to go and ask those electrical engineers. who make the parts for the computer, they would explain this a bit better because they understand the hardware. So this is very important. If you check, every single programming language has a main function. That's how important a main function is. Some functions might not necessarily return zero. In other programming languages, some main functions, but it's important for the operating system to know that everything went well, right? So that was a lot of explanation, but you finally get the picture. So how would you create a string constant, right? So let me make an example. You'd use the keyword const, right? Followed by space and the variable, not what am I saying? The data type, and then space, and then the variable name, and then space, and then equal sign, space, and then a value, and then a semicolon. Do not forget the semicolon, because if you don't put in the semicolon, computers are not like human beings. I know these days you send a message on WhatsApp, you don't put in a full stop, right? There's nothing wrong with that. But a computer is gonna shout at you. It's not gonna work. It's gonna tell you put the semicolon. It needs to be there. So that's why I always have to put it there. So how would I define a string constant? I would use the keyword const followed by its data type. The data type is string. It's called string, right? So string, okay, string, and then space, and then the variable name. So it depends on the variable name that you want to, the problem you're solving. In my case, right, remember we're solving a problem about selling sweets, right? I want to keep track of the profit. So for you, they say the name of each week. So meaning week one, week two, and so forth. You need to store that. And I forgot to tell you something very important. When you're creating constants, right, the variable name you should use only capital letters. Don't mix, don't only capital letters. It's strict like that. You need to follow those instructions. So let's say you wanted to create, for example, week one, you'd say int, right? Because it's a string. String, and then you say week one. Week, you need to write it like this. And then you can write week one like this, that's fine. But then there's also another rule that says if you have more than one word, right, separate each word using an underscore. So if I have week one, even if you have a number and a word, to separate those things, you must use underscore. So you can use week one, you can name week one like this, which is a little bit better, right? Compared to just saying week one. So that's me. So for me, I'm gonna have Monday like this as a constant, and then it's gonna store the string. Remember to create a string, you must use two sets of double quotes. The first set of double quotes is to open the string. The other set of double quotes is to close the string. So open, close. Then everything in between them is a string. Even if you say 1 plus 1 like this, when you output it, it's going to output 1 plus 1. It won't calculate, it won't add them up and say 2. No. A string, it means literally copy and paste everything that's in between the double quotes as it is. Don't change, don't do anything, as it is, including the spaces. So if I put space on one side and then I don't put it on the other side, it's going to output it exactly like that. That's how strict a string is. So I don't need to worry about that because I just want to store words. So I'm gonna call this one Monday. Why are we doing this, right? Okay, let me not write it in full. Let me say man like this, right? Remember, that's how you abbreviate Monday. You just say MON. Why are we doing that? Because if you look at your practical, it's supposed to output W1. I wouldn't advise you to say W1 because what is W1? You won't know in the future when you look at your practical. Let's say 10 years from now. So I suggest you say week one and then week two. So for me, I'm using Monday and Monday up to Friday. So don't be like me, right? Do not do this. Do not copy and paste. It's very dangerous. I have experience. I know where to change, so I can do that. You have to type in everything. So this is one string, and then I need like 5 of them, right? Remember, it's Monday to Friday. So this would be TUE, and then Wednesday is WED, Thursday. Thursday is what? How do you abbreviate Thursday? I'm just gonna say THUR. I'm just gonna leave it like that. And then Friday, I'm just gonna say FRI. That's it. So there's my constants, but I'm not done yet because one thing about programming, right? If you name things exactly the same way, it's gonna show you an error. So if I try to build this, right, I'm just gonna do one thing. I don't wanna run it. I just wanna build. See, you see that it already shows me an error. It says redefinition. That means you are creating it again. It's not allowed. It has the exact same name. You need to give variable names that are different. Even in, but then one thing about C++, right? It's very tricky because if you change one, if you change one letter and you, let's say, let's say on the first Monday it's in all capital letters, right? But then here in the other Monday, I only change one letter to be a small letter. It's gonna think that those are two different words. You see, it skipped. You see now the red square is no longer on line 6, it's now on line 7, meaning that it allowed it to exist. That's how stupid a computer can be. So you need to be very careful with how you're naming variables. So this will be Tuesday, and then this will be Wednesday, and then this will be Thursday, and then this will be Friday. So this is what they mean. This is what they meant when they say you must create string constants, right? You must use the const keyword and the string data type. And they give you an example of what the values should be. Simple, straightforward, right? Nothing too fancy there. And then calculate the average weekly temperature using a C++ expression. By C++ expression, they mean just like in maths. Remember in maths, you would say 1 times 2 to just 2, right? So this from 1 up until 2, this whole thing that I've highlighted, we call that an expression, a mathematical expression, right? In C++, we're just going to call it a C++ expression because we are inside C++. But when you write it in maths, it's a mathematical expression. But when you're inside C++, we call that a C++ expression. And you can use maybe plus. When I say 1 plus 2, it's still an expression because there's this operator here, this plus. It's what makes it an expression. So we need to understand a bit of the operators in C++. But like I said, watch that video. I explained all of these things thoroughly. So we have plus, and then we have minus, we have divide, no, we have modulus, and then we have divide, and then times. So this is how you'd write it inside C++. So this would mean, so let me do this. So this would mean plus, and then this would mean minus or subtract, and then this would mean modulus, right? I know you might not be familiar with modulus or mod. It's sometimes also called mod or remainder division, right? Which just means that if you use this symbol here, it's going to divide and then give you the remainder, right? That's what it means. And then this forward slash, and don't confuse this forward slash with comments. Remember, comments is two of them. If it's one like this, it's a division sign. So do not make that confusion. So this is division, right? Meaning I'm dividing. But then this is what we call most of the time when you use it's specific. There's integer, then there's floating point division. It's different. I'll explain what I mean by that. So this would be multiplication, right? That's multiplication. So before we do that, let me show you the division, what I mean by division. Computer C++ is very tricky. You need to understand what you're doing. So C out, right? And then I'm gonna put in these two characters to point in that direction because I'm sending it to this place, to the terminal. Then I'm just gonna say C out 1 plus 2, right? And then I'm gonna build and run. Okay, you see that it does work, right? It's showing me 3 because it calculated. And then I'm gonna now try to divide, right? So let me make let me use numbers that will be easy to divide. So this will be, let me see, 1 over 2, right? So 1 over 2, it should show me 0.5, right? But then look at the weird thing about C++. It's going to show me 0. So there's the answer is 0. And then you're going to be like, why? Why is it showing me 0? Well, the more advanced reason to that, right? You can go you see, that's why I always suggest you guys read the textbook. All these answers that I'm getting, all of these answers in the textbook. Before I make a video, I go read this very same textbook they told you in class to read. So there's nothing special about me. You can know what I know by just going to read the textbook. If you made the decision to come to university, that means you made the decision that you want to come here and study, not to have fun. You can have fun after you've studied and you see you got your results, you got distinctions or whatever, you've passed, right? Then you can be like, oh, there's a reason for me to go out. I'm going to celebrate my passing because I've passed my modules. Not like you just celebrate and there's nothing to celebrate. This is life. You're gonna realize after you graduate, if you didn't get good marks, life is not gonna be nice to you at all. You're gonna be going interview after interview and you're not getting the job because you didn't take school seriously. Because remember, you not taking school seriously, there's someone else in class who's taking school seriously, and then that person might, and not even him only or her only. There's gonna be a lot of them, and then all of those people that you apply, and it's just UJ. There's also VETS. There's also UCT. There's also Stellenbosch. There's also colleges. So your competition is very high. Even if you're doing, I don't care whether you're doing a degree in comp sci or accounting. It's the same. The same thing applies. Every time you apply, they say send us your academic record, so they see your results. So it's very, very important that you take school serious. Me, the advice that I give students, right? Study every qualification like your life depends on it, like you're doing medicine. Just you see, if I have that mindset that, oh, this degree is exactly the same as like me studying medicine, you're never gonna have any problems in life. Bursaries are gonna come to you, and then bursaries you can get up to 5,000 a month in stipend, in allowances, provided you're getting distinctions, you're passing. Yeah. And how do you do that? By reading the textbook. So very important to read the textbook. Start by reading the textbook, then you can watch videos or Google or whatever you want to check what answers, whatever, ChatGPT, all those things. But you've read the textbook first. Because and to be honest with you, all the answers in the textbook. And it's very important that you get good marks because when you graduate, you're gonna apply with people who don't waste time, who are getting distinctions one way, and it's not like they're special. Always remember, no one's special. It's all about how much effort you put in and your study techniques. You can, if you don't know how to study, ask them, ask the geniuses in class, ask them, how do you study? I find the textbook boring. How do you study? How do you read that thing? It's too thick. Then they're gonna tell you, oh no, you can break it down. Do this one chapter maybe today, and then tomorrow another chapter. Maybe this. They have different strategies. So learn to read, learn to work, learn to take yourself serious. Just do that. So that's a bit of advice on my side, and I hope you take that advice. There's nothing special about anyone. Even people who become doctors, there's nothing special about them. We are all the same. It's all about how much effort you're willing to put in. There's people who come to school or to university, they don't even know English, but then they manage to get distinctions. So, yeah, if you really are serious about it, you can do it. So, let's go back to the practical. So, I was explaining the division, right? So, there's something very important about computers, right? So, when you write one plus two, right? There's something called a processor that does this calculation. For example, I want you to view the process as like your calculator. Like when you take a calculator and you say 1 plus 1, and then you say is equal, and you press the equal sign on the calculator, it calculates, right? So the processor is like that. The processor, the way it's structured, right? I want you to view it in this way. If you add an integer plus an integer, you get back an integer. It's as simple as that. It's not that complicated to understand this. That's how a processor works. So that's why when I divided by an integer, I got back an integer. But there's a very important rule to understand. You can change you can change this formula. How do you change it? By making one of the values, right, a different data type. So if I say an integer divided by a double, the processor, what it does, right, it's going to look at the size. How big is this one? And how big is this one? And then it looks at the one that's bigger, and then it forces the other one to be converted to the other type. So double is bigger. So what it's going to do is that it's going to promote this one or change it, right? And change it to become a double also. So that means I'm going to be dividing a double and a double. Then I get back a double. So that's how easy it is to change the structure. So if I have an integer here as a numerator, and then I have a denominator as a double, it forces the numerator, it changes or it treats the numerator as a double before calculating. Then it calculates the division of a double and a double so that it gives you back a double. Why does it do that? Because doubles or float, right? Double or float, it always is always bigger than integer in terms of space in the computer. The integer is smaller than a double float always. So that's why it always promotes to the bigger one, right? Which makes sense. And it can be any order. You can have the numerator as the double, like this, right? Double, and the denominator is an integer, but it will still force one of them to be converted to the bigger one, which is the double, so that it gives you back one type, because the processor is like that. It can only calculate things that are of the same type, which makes sense. Think about it, right? It makes sense. It makes sense, not as advanced as us, right? The way it views it, it's like, can you mix water with cooking oil and get something reasonable there? Nope. So that's why a computer is like that. It views things like that. It's like, no. If I have cooking oil and I have cooking oil, if I pour cooking oil inside a cooking oil container, it's still cooking oil. They're gonna mix together into the same thing, which is just cooking oil, which makes sense. Imagine if we did we if imagine if also human beings didn't have that common sense. We would okay, let me make an example so that you can really understand. Imagine you went to Pick and Pay, and they sell you a container, and they tell you inside there's cooking oil, there's stay soft, there's washing powder, there's sunlight liquid in one container. Imagine if that was the case. Wouldn't that be wouldn't that be that would be very crazy, right? That would be weird. I'm sure they'll get sued by some company, and they'll have to pay a fine for that, because you cannot mix things that are not supposed to be mixed. So a process is like that. If you have cooking oil and cooking oil, makes sense. You can't say cooking oil and you want to mix it to stay soft. Well, why? That's a computer. That's the processor. That's how it views things. So you must force one of them to be the other one. How do you force? So when to force one thing to be another thing, we call that casting, right? Casting, right? Another word for casting is, which is a very fancy English word, it's cohesion, right? It's just a fancy way to say cast. Cast is just a fancy way to say change to. So it change it, meaning change it to this, whatever the other thing is. So that's basically what we're going to do. So how do you do that in C++? The It depends on the, okay, if you have numbers, right, if you're working with numbers, we have what we call literals, right, which means it's literally the thing. So what do I mean by that? So let me make an example. Let's say we have an integer literal, which means it's literally an integer. There's no other way I can explain it. That's literally what it means. No pun intended. It means literally that thing. So what examples can I make of an integer literal? One. If you write one, it's an integer literal, meaning it's literally an integer. But then there's other ways whereby you're using a variable. So for example, remember I have a variable that stores my Monday's income, and I called it Monday. It's still an integer, but it's not a literal. So I need an extra step to cast or change it to be a double. I need another way to do that. This one with the one, right? We see with literals, right? It's easier to cast or to convert. Okay, another word I can use is to convert. Casting, cohesion, convert, one and the same thing. It's synonyms. If you remember synonyms in high school, these are all synonyms. They mean one thing. English is like that. I'm sure you are used to it. There's multiple words to describe one thing. That's English. But then in C++ or in programming, we call that the proper term is called cohesion. Then there's another word called casting. So there's many ways to do that, to explain that. So one, right? If it's a literal, it's easy to convert to a double. How do you do that? Simple. You use common sense. You just say zero point 0, and now it's officially a double because that's how C++ works. If it sees it like this, it's gonna treat this as a double. So if I say 1.0 divided by 2, even though this is an integer, it will treat it as a double so that it gives you back a double. I want you to really understand that part. So let me change one thing. Let me change this to 1.0. 1.0 is still 1, right? Even okay, for those people who are maths geniuses, right? Whatever, they'll be like, yeah, it's not the same. Yeah, I understand what you mean by that. Because this is point 0, and then that's just 1. Point 0 technically you can say it's bigger, but that's not the purpose of this tutorial. It's not a maths tutorial, right? It's a computer science tutorial. So I'm just going to say 1.0, which is technically the same as 1. So now you're going to see a surprising output. So I'm going to click build and run. And then now you see 0.5 magic, right? And it doesn't matter in what order. You can change the new numerator, or you can change the denominator. So let me change the denominator to just 2.0. The processor forces one of them to be treated as the other one to be a double again. So you only need one to force the processor to do that calculation for you. So you see, and now it works. So that's why I decided to make the video so that you guys really understand. I explain these things because you are going to fail to output and you're gonna get wrong marks, or you're not gonna get full marks. Maybe 60 something percent. That's what you're gonna get at most, because a lot of the things you're not going to know how to fix that. But then, like I said, everything that I'm saying right now, it's literally in the textbook. Go read the textbook, you'll be surprised. I know it's big. Mind you, you don't have to like it to do it. Till this day, I don't like reading. I try to avoid reading as much as possible. I don't like it. But since I have to make a video for you guys, I'm forced to go read it. So the main important thing in life, right, is to have a reason. If you have a reason to do something, you do it. For example, you come from a poor background, you'll study, you will read the textbook because you don't want to go back there. You want to better your life. So always find a reason, then you'll realize that the things that you say are boring, they're not really boring because you have a valid reason to do them. So look for a reason to start. You guys, I'm not joking. You guys need to start. There's now this thing called boot camps. There's students who go to get trained for 1 year or 2 years. Then they go for interviews. They're competing with you guys. And Bona, they have way better experience because they work hard. They read every day, all day, and they don't like it. You ask all of them. No one likes reading. I don't. There's a select few of people like reading. People don't like reading, but you have to do it. It's life. We want to become better people, right? You want to be able to buy your parents a house, things like that. Read the textbook. And I know some people are still not gonna read the textbook. That's your own funeral. You'll be waving and clapping hands for other students at graduation when it says passed with distinction. And that'll be your own fault. You must just look in the mirror and see, oh, that's my fault. I didn't work hard enough. So there shouldn't be any jealous. Don't be jealous of other kids who are getting high marks. They are working extremely hard. So Monday, let's go back here. And I'm gonna keep reiterating. I'm gonna keep telling you guys, read the textbook until you read the textbook. So now we understand how to convert if it's a literal integer. I can easily convert it to a double. But what if it's a variable? Well, I have to tell C++ to cast it to a variable. How do I do that? I put in round brackets, right? Before the variable name. It's always before the variable name or in front of the variable name. You put in round brackets. Then inside here, you specify the data type that you want to convert it to, or that you want it to treat it as, right? So it's currently an integer, and then the data type that I pass it here, it's gonna treat it as that data type. And I'm gonna repeat this again, right? Do not ever do spiritual things. Don't try to cast to an integer. Do not try that to a string. I mean, do not try to cast. Do not try and put string here. Do not do that. Those are very spiritual things. Don't do that. You only put number. You only put data types that are related to numbers, doubles, floats, integers, shorts, all those ones that are related to numbers. So this will be the first way. So how do I convert it to a double or get it treated as a double? I do it like that. So this means that I'm telling this guy over here. Remember we talked about processor, the processor, right? That guy's gonna be like, oh, so you want me to treat this as a double? So behind the scenes, right? Imagine Monday. Okay, Monday has like 50, right? So imagine behind the scenes. Remember when you everywhere where you put a variable, it's like I'm telling the computer to go take the value inside of that variable and put it where I've called the variable. So if you see Monday here, the computer is gonna go look inside its storage, wherever it stores it. Then it's gonna take its value. Oh, it's 50. Then it puts 50 here, like this. So that's what happens behind the scenes. So the thing is, it's not literally this. I can't say point zero, and I think common sense should explain why. So let me show you. I can't say Monday and I say point zero. That makes no sense. The computer's just gonna complain. That's not how it works. You'd have to do it this way. Then there's another way, but then that other way is a bit too advanced, right? For beginners. This is considered unsafe, but then for now, that's fine. So let me put back Monday there. Yeah. So this is considered a bit unsafe, but for you guys, you're beginners, it's fine. I, I'm gonna teach you only this way. In other tutorials, I'll teach you the other ways. So now let's see how I can calculate. Let's go to the next step, right? I'm supposed to do what? Calculate the average weekly temperature. So let's calculate the average. But to calculate the average, remember there's two steps. You need to calculate the sum, then you take that sum, and then you divide it by how many things you added, right? That's the simplest formula for average. So since I'm calculating a sum, right, I'm adding integers, right? So I expect to get back an integer. That's why I'm going to create a variable and then I'm going to use int as this data type. Then I'm going to call or use these variable names, right? Remember what I talked about. Where you call the variable name, especially if you see this line over here, I was still making it available. I was still declaring it. This is what we call declaration and initialization. Initialization because I gave it a value. You see this equals to 50. That's what that part that I've highlighted, we call that initialization. I'm giving it an initial value. Initial is just a fancy word for a starting value where it should start somewhere. That's what it means. Then now whenever you call it after you've declared it, right? And you say, if I come here and I say Monday, it means I'm telling the computer to go fetch 50. That's what it means. And then remember, I need to calculate the sum, so I need to add all of them up. So plus Tuesday, plus Wednesday, plus Thursday, plus Friday, right? and then semicolon. Do not forget the semicolon at the end. So let me zoom out a bit so that you can see everything. So there is, I said the sum is equals to Monday's value plus Tuesday's value plus Wednesday's value plus Thursday's value plus Friday's value, right? Straightforward, right? So I'm gonna put a comment here and say I'm calculating the sum, right? And then I'm gonna put spaces just so that it looks a bit clean, spaces in between. And then here I'm gonna put a comment and say calculating the average. Um, so okay, yeah. So I think this is a bit better. You can see my everything that I type. So I want to calculate the sum. So the sum is simple, right? It's just the average. I mean, we need to calculate average, which just means that you just store it. Remember, remember talked about casting. You need to convert one thing to be treated as a double. It's gonna be treated as a double. So I'm still at question 3 because that calculating the average is still part of question 3. Then I'm gonna go back here and then I'm gonna say it's a double, right? So double average. So its name. You see, look at the way I'm naming my variables. It's easy for me to understand what that variable stores. If you just say av like this, AVE, I wouldn't know. This could mean avenue, a street address. I don't know. So that's why it's or A. What does A mean? I don't know. So you need to give it a proper name, average, and say it's equals to sum, right? Which is that sum divided by how many things are there we have, or how many days, right? For you, you're gonna look at how many weeks. So I have 5 days, right? So it's gonna be divided by 5, like this, right? But then I didn't think about it. But then in my case, I just wanted you guys to see how to cast, right? To convert to a double. In case you only had variables. Here I happen to have what we call a literal, and I have an integer literal, which is 5. So I can, instead of saying this, right? So there's two ways you can get the actual average, the correct one. So let me show you here. Let me do this. Let me output the average so that you see that I'm not joking when I say it's not gonna display. It won't display the average properly if you don't make one of the, whether the numerator or the denominator, you don't make it as a double. You see, this is not a double. This is an integer. Why is this outputting an integer? Because the processor, it processes only it does calculations based on the things that are of the same data type. So I have to make sure that I tell the computer to treat one of them as a one of them as a, what is this, as a double. So since I have a literal, I'm gonna choose the easy way out. I'm just gonna say point 0. Done. That's the only smallest change that I need to make in order to get the correct output. Then I run, and then there is, okay, so that means it, okay, lucky enough that, let me change it so that it actually shows. Let me say, let me put in um 7. Let me put in random value. I think it evenly added up, so that's why it wasn't showing. So you see now it's 176.4. So now it's showing the 0.4 because that's important. It needs to show it. So yeah, that's how you calculate the average. And there's still quite a lot involved here. I think we're gonna have another live session tomorrow, right? Because to be honest, there's quite a lot to share. Because in order for you to display all of this in a table format, it's not easy. This is C++. It's not that straightforward. There's a lot to explain. So I think, let me see. I think we can stop at number 5. Then I'm gonna leave 6 and 7 for tomorrow. So that means tomorrow's tutorial will just be short. So create const variables to store the necessary terms. By terms, it means that you see here at question 7 what you are displaying. So it means create a string constants that we're going to use to store the labels of for the averages that we are calculating. For me, I'm not calculating an averages. I'm calculating the sum and an average. So these are my constants. So I'm gonna come here and then I'm gonna say const. Remember, it's labels, so I need to use the string data type. So string, and then remember it's in capital letters, all caps. So I want to store sum, right? For me, remember I have average for I have sum and average. You guys have two averages. So what I suggest you'd say maybe average and say Celsius. That's for the Celsius average. Oh, and then you have another average. You say average Fahrenheit, right? Something like this. That's up to you. Or average underscore F, or others, and then others average underscore C. Up to you. That's up to you. To be honest, it's up to you how you name your variables. They just need to make sense, right? So for me, I only have two strings or two labels. Sum, of which I'm just gonna say sum and a semicolon like this, and then const string average is equals to, and then I'm gonna say average and then colon there. And then this should be all the string, the constants that I need. Even for you guys, it might be a bit more. For me, this is only the ones that I need. These last two, right? They should be there even on your side, but then it depends on what you're displaying. You guys are displaying two averages. I'm only displaying the sum and an average, right? So let's do that. So let me go back here. Okay, so that the output looks good, right? I know it's a subtle thing, right? Remember what you talked about strings. It copies exactly what you told it to do, which is this. So yeah, if you don't put spaces, for example, put space here, your output is not gonna look good, but it's fine. We'll see when we get to that. So I've answered question 4. That's done. Those two constants that I created, I've answered them because here, okay, it coincidentally it's gonna be the same for you and me. You also need to create two constants, but then your constants needs to be average, right? Both is average. For me, I have sum and average, so you must create two labels. Then number 5, convert the average temperature from degrees to Fahrenheit and store it in a double variable. So convert the average. So actually, so that was important for me to teach you. You see, convert is remember I told you it's another term for casting, right? Where is that part? It's another term for casting or cohesion or convert, which just means this, doing this. So that means you must take that variable that stores the average in degrees, then you're gonna cast it, then you store the answer. So how would you store the answer? Because let me not assume you guys know what understand how to do this. So this is what they mean. So it may, for my example, right? Let's say you wanted to convert the sum to a double. So I'm gonna say double. I'm gonna call it I. Doesn't matter. Is equals to. So this I variable should store the sum in a double format. So let's say previously the sum was an integer. So int sum is equals to 100, like this. Before remember they said you should convert it to a double. So to convert it to a double, I would have to come this side, and then I do this round brackets in front of the label, in front of the variable. Then you put in the type that you want to convert it to. So I want to convert it to a double, so I'm going to put double here. If you wanted to convert it to an integer, you would have to put int. You just simply put the data type of that you want to convert the variable to. That's how straightforward it is. So this is how you should answer question number 5 or step 5. And then they told you to store it in a double variable. That's why I declared it as a double, because they told me to store it in a double variable. In my case, I just made a simple example. I'm not gonna do this when I'm solving the problem, but I just showed you how to answer step 5. And then this output part, for me, like we're basically done. But so this practical is actually not too hard. Basically done. Okay, to Fahrenheit, right? Let me also correct something. Yeah, let me correct you guys on something very important. When they say convert from degrees to Fahrenheit, remember there's a formula. It's this formula over here. It's not gonna be as simple as saying what is. It's not gonna be as simple as saying is casting like this, right? So this was just an example. If you want to cast, for Fahrenheit, right? To convert it to a Fahrenheit, you must use this formula. It means take the degrees in this variable that stores the degrees, times it, right, by 9, and then divide by 5, and then add 32. Don't forget to put the brackets too, right? You see these brackets over here. You can also put them in C++. Remember, that's allowed. So let me make here an example. Okay, let me make an example. Let's say I want to take the sum divided by the number of things that are there. Let's say 5, and then add 2. Let's say this was my calculation. Remember BODMAS. People tend to forget the things that they were taught in high school. Everything is important. There's no such thing that's not is irrelevant. It's still relevant. Some they remember is as, I think, is it PEMDAS? I think it's called PEMDAS. Oh no, it's PEDMAS. I forgot. I think it's PEDMAS for some people, right? Which means you start with what's inside the parenthesis. That's what the P stands for. Parenthesis is just a fancy word for brackets. And then E is exponentiation, meaning exponents. If you have any exponents, x squared, y squared, you start by calculating those. Then you get to division, then you get to multiplication, then you get to addition, then you get to subtraction. And then BODMAS, if okay, some people they remember, some they know it as BDMAS, which just means you start with what's in the brackets, then division, multiplication, addition, subtraction. For some, it's BODMAS. But I think the O was just there to make it easier to understand. I agree. They'll say brackets off, meaning solve what's inside the brackets to remove the brackets, right? Then you get division, multiplication, addition, and subtraction. So order matters. In this example over here, right? Lucky enough, division is done before addition. So the brackets are not necessary. But I'm gonna reiterate and tell you again, brackets you should always put them there, even though it's easy to understand, because it can get complicated easily, right? For example, let's say I realized that I was not supposed to add, I was supposed to times, but then I'm supposed to start by multiplying. In C++, right, it does what it call it's left associative, right? The operators in C++ are left associative, meaning if they are the same, if they are if they have the same, it's called precedence. If they are of the same precedence or of the same value, right? Meaning that it's supposed to be done this at the same time. So division, you can remember they weigh the same. I'll just basically tell you that they weigh the same. That's the only best way to put it. That means it's going to start from the left going to the right. But me, my formula tells me that I need to start by multiplying first. You see that your answer becomes incorrect because it's going to say sum divided by 5, which is going to be 20, then times 2, which is 40. Instead of saying 5 times 2, which is 10, then take 100 divided by 10, then the answer is 10. So the actual answer is supposed to be 10, but you're going to get 40, which is very incorrect. So that's why I always advise you to put brackets, even if it's easy to understand, because the formula can easily change. Maybe in the future they tell you no, to convert to a Fahrenheit, you need to no longer do this. Now you need to do this. So now you need to change. So the brackets are always very important. So this is how, and then don't forget the semicolon. It's very important. And then this is how you would approach it, right? This is how you'd use this formula, right? The brackets are important. And don't forget about division that we talked about. Don't say 9 divided by 5. Because remember, this is an integer. Remember, your degrees is your degrees are in an integer format. This is also an integer. This is also an integer. 5 is also an integer. And 32 is also an integer. That means you're not getting a double, which is going to be incorrect. So that means you'd have to either convert 9 to a double or 5 to a double. The 32 doesn't matter, right? the 32 is outside because remember it's division here. We want to get the remainder also. You want it to say, if it's supposed to say 2.5, it's supposed to say 2.5. If you leave it like this, in programming, right, in C++, it truncates. So this thing called truncation. So if you just do integer division, C++ does this. In starting from the dot, right, going to the right hand side, it deletes it. It disappears like that. So that's why on the output you're gonna see 2 instead of this 0.5 that's out there. It throws it away. So that's why you need to make sure that it doesn't throw it away and treat one of the, whether this is the numerator, whether treat the numerator as a double or the denominator as a double. So that means you're gonna say 9.0 instead of just 9. Or you can just say 9 divided by 5.0. That's up to you. But make sure you treat it the right way, or else you're gonna get incorrect answers. It might look like a simple practical, but there's a lot involved in this practical. It's the little things that you need to understand. So I think that should be it for today because there's quite a lot to explain, especially the outputting part, right? For now, what I suggest you guys do, right? Go to the textbook, read the I think it's chapter two. Is it chapter two or chapter three? I think it's chapter three. Go read on input and output. You'll understand better when we go through it tomorrow. So you're gonna learn things. There's this thing. These are the things that you're gonna learn about. So when you see out, right, when you output, you can either output something that we call an expression or a manipulator. Not people that are manipulating, whatever. Not that. It's just called a manipulator, right? Because it's meant to manipulate or meant to change something, right? So those are the things that you can output. And please, guys, this is an example. Do not try to write this in C++. This is very spiritual. You don't. This is impossible. You can't write this because it's gonna ask you, what is this? It's gonna ask you that question. So it's gonna crash, and then it's gonna ask also, what is this? So this is just an example. So let's start with an expression. We did make an example of an expression. An expression is just something like 1 plus 2. So it's going to output 1 plus 2. And then the manipulator part, right? Remember I said, okay, let me use or like this, so that maybe it's a bit better. So that you don't think it's division. I just mean or, not division. So you can output an expression or you can output a manipulator. There's many manipulators out there. So there's the fixed manipulator to show the decimal numbers in fixed form. Then there's another one called show point. Show point is just means show, even if you get, remember C++ is very, no, it's like there's little things in C++ that need to be taken into account. If you don't take them into account, your code is not gonna work. So let me do that. So show point, what it does, right? We go into a bit more of it in more detail tomorrow. So show point is like, for example, if your answer was 2.0, C++ is going to display it as 2. That's the problem in C++. So you have to use the manipulator to tell C++ that no, even if it's a point 0, show it. I need to see it. So if you read this word show point, it means show me the point, this dot. Another word for dot is point. Actually, you're gonna say 2.0. So show point, it means show me that point, even if it's a dot zero. That's what we call the manipulate. So this line of code does that. So this is what you're gonna be dealing with tomorrow. There's quite a lot. There's a lot of them involved. There's a lot involved. So I don't want to touch into that because that means I'm gonna spend an extra hour, which means the stream is gonna be like almost 3 hours, which is too much time. I'm sure you guys are already bored right now. Some of you already left the stream. So I think I should just stop here. Let me check if there were any questions. Is it possible to access the video at the end of the live? Yes, it is possible. I'm going to you see the immediately right now when I stop this live, it saves it automatically. You don't have to wait. So I'm gonna share it immediately after I'm done streaming. So that's it for today. We'll continue on the output part. The output part, you'll understand what I mean by output, that it takes a lot of time. There's a lot involved. There's set width to set the width, like how many columns. There's what there's a lot involved. So for now, I suggest you guys go read the textbook. For those who haven't watched the live, who are not part of the live, they can just watch the recording, then read the textbook, so that tomorrow we continue where we left up. The only thing that's left is just output. So that's it. Thank you guys for watching. See you tomorrow.